Guys, what's up? Mr. Gagnon again. This is the third video series of dynamics, and we're going to get into a thing called net force. Net force. So now, what I'd like to do is, again, this is a story I would tell, but back about 5 years ago, I ended up doing a tug of war at the Spirit Week. And what happened was, okay, so here's the rope, right? Now, you're going to notice that in all of physics, that this rope, tug-of-war rope, is going to be something that's going to help you out for the rest of the year with everything. And I'll explain why. All right, so let's say I have a rope here, a tug-of-war rope. And in class, what I would have done is gotten the tug-of-war rope that they use every year, and I'd let you guys have a tug-of-war with each other. But now we can't do that, so let's pretend. All right, let's say I take All right, let's say we take Cody. All right, Cody's here. Okay, he's a pretty tough guy, pretty strong. So this is Cody. And then we, on the other side, we put Mr. Gagnon. Okay, and Cody is giving me the look, and he's like, "Hey, I'm gonna pull you." And this here is a pile of what I want to say is pile of. Let's do it. Pile of trash. Okay, there's a pile of trash there. All right, so if Cody wins, if he's got more force than me, he's gonna pull me into that big pile right there. So hopefully he's not stronger than me. But let's say Cody actually pulls with a force, and we're not gonna get into like the units yet, but let's say he pulls with 150 pounds. This way. So can I call that positive? Yes. Okay, let's say Mr. Gagnon pulls with a force of 150 pounds negative, okay, to the opposite direction. Well, here's the question. The net force is the addition, and I'll put that up here, addition of all forces. Okay, well, let's do it. Let's find out what this net force is. I'm thinking that you probably already know what it is, because if I have 150 pounds pulling this way, and then I have a 150 this way, then my net force, and we're going to give you a new term here, net force is equal to 150 positive, 150 negative is 0. So this little deal here balanced out. Okay, so this balanced out completely. All right, so now remember what I told you about Newton's second law. I said that F equals ma. Now I'm going to add a little thing here. That's net. This means net. Okay, so that's net force is mass times acceleration. So tell me something. If my net force is 0 in this situation, and you got two masses, you've got me and Cody. Let's just say that we together we're 300 pounds times A. Well, look, 300. Do we have an acceleration here? Is there any acceleration? Do we have any movement there in the rope? Okay, answer is no. Okay, in fact, if we set these up, okay, acceleration is 0 meters per second squared. No acceleration. So they're even. The net force is even. Nothing. 150 to the right, 150 to the left. Now I'm going to give you guys one more analogy. Okay, hopefully it helps you. And I'm going to talk about teacher paychecks in a second. Okay, so let's say this particular day, and Cody, sorry to pick on you a little bit, but I know you can handle it. That's why I'm picking on you. Let's say this particular day, Cody decides to eat Wheaties, and he's feeling extra strong. And he says, well, I'm going to pull Gagnon into that pile in the center here. So he says, I'm going to eat some Wheaties and have some coffee and get all ready for this. And he gets up some extra strength, and he has 152 pounds. Okay, he has 152 pounds. Well, let's see. If I draw my line here, negative 150, positive 152. Okay, let's see. There's a little bit of a vector left here. A little bit of a vector, and a vector is just an arrow attached, just an arrow to show forces. We have a positive 2 pounds. So even if he pulls with an additional 2 pounds of force, guess what? Our masses are now going to accelerate. So he's going to start pulling me, and I'm going to show movement toward the middle here. Okay? So the net force, in this case, net force. Okay, so the 2 pounds in the positive direction is the net force. All right, so now on to paychecks. Okay, so paychecks. I know some of you guys already have jobs, and if you don't, then you can relate. If you do, then you can relate to this. But let's just say you get your paycheck, and I'm going to put a random number here. Let's say you get $1,000 in your paycheck. You jump for joy because it's like, wow, I made $1,000. So this is something that's called, I'm not going to write it down, but this is something that's called gross pay. Now, what I'm really interested in is what I'm going to have left at the end of the deductions. So there's something called net pay. Okay, and you parents can probably solidify this idea with your kids. So let's say I take $1,000 in my paycheck, and then I take 100 out, and then I for retirement. Then I take 200 out for taxes. Then I take 100 out for something else. Okay, it doesn't matter what it is. My net pay, what's left. Okay, what's left is going to be what I'm really concerned with, right? That's how much money I can actually spend. So let's say I have 1,000, I take away 100, it's 900. Take away 200, that's 700. I take away 100, that's 600. So something that I'm more interested in is my net pay. Okay, just like we talk about net force, what's left? Okay, I'm concerned with what's left. So look, simple situation here. Let's say, and we're going to stop using pounds shortly because pounds aren't really the right unit for force. So what's left? So let's say I have 100, and we won't even use units here yet. 100, and then I have 120 this way. What's left? 20. Okay, we'll do a couple more. If I have 60 to the right and I have 30 to the left, what's left? Okay, 30 to the right. Okay, let's look at up and down. Let's say I have 20 down and then 10 up. What's left? So 20 would be our negative, right? What's left is 10 down. Okay, let's just look at one more. Let's say I have 10 up and 6 down. What's left? 10 subtract 6. I'm still in the positive. I still have 4 up. Okay, so net force is not that hard to understand, or even net, the term net, but we're going to start applying it to some more difficult physics problems. Okay, I'll leave you at that. I went over time a little bit, sorry. Until next time.